Okay, we're going to be talking about thermoregulation. And thermoregulation is a production of the work between the cardiovascular system, muscular system, nervous, and integumentary systems. And this ensures that your body temperature is maintained at around 37 plus or 1 degrees Celsius. And the production of body heat is always proportional to your metabolic rate because heat is a byproduct of metabolic reactions. And if we have excess heat, our body temperature is going to continue increasing and our body just can't handle that. That's why fevers always feel really horrible. So there are mainly 4 sorts of ways that heat is transferred through the body. And the first one is radiation. And radiation is the transfer of heat via infrared waves between 2 objects. And this means that your body doesn't actually have to be touching an object, but the heat can be radiating outwards. So for example, if you're standing in a colder environment, your body will radiate heat outwards because there's a difference in temperature. And things always go through gradients. It always goes from high to low. So there's high temperature here and there's low temperature in the air. Therefore, the heat comes out of your body and into the air. That's radiation. The second one is conduction. And conduction is the transfer of heat through direct contact. So if you put your hand on an ice cube, heat is lost from your hand, and that's why the ice cube melts, because the heat is going through from your hand into the ice cube, and it heats up the ice cube, and the ice cube melts. That's conduction. So it has to be direct physical contact between 2 surfaces. And this can also work the opposite way. If you are already sweating and you're leaning against a wall that is really hot, the wall will transfer more heat to you and your temperature will just keep on rising. And the third one we have is convection, and convection is the transfer of heat through the movement of air or liquid across your skin surfaces. And heat loss is enhanced by moving air, which is why you feel cooler when the wind blows across your skin. And when we say air or liquid, the only 2 we have are really just, like for sporting examples, are just wind and moving water from swimming. So swimming can allow you to cool your body down because the movement of water is allowing your skin to cool down. And then also your blood moves from your core to skin via convection because blood is a fluid. And then the last one we have is evaporation. And evaporation accounts for most of heat loss during exercise because evaporation of sweat is how we're able to get that heat out. And that's the heat transfer when water goes from a liquid into gas state, and it is increased when there is an increased heat production within your body from metabolic demands, and you want to get rid of that heat, so you sweat more into the environment, so the heat is lost through evaporation. And your sweat response is controlled by 2 things. It's the density of your sweat glands per centimeter squared of skin surface, and also the amount of sweat you produce per sweat glands. And the maximal evaporative heat loss you can have is the combination of density and amount of sweat per gland, which means the more you have, the faster your body will be able to cool itself down. So that's why sometimes when you're sick, you try to get a small child to sweat more so they can get rid of more of that excess heat and lower their fever. So that is methods of thermoregulation and transfer of heat.